Let's find a few quartiles. So reminder, a quartile is similar to a percentile, whereas a percentile separates your data into 1% chunks. The quartile more roughly chops it up. It's into 25% chunks, right? I want to separate my data into, as the name suggests, quartile, 4 different sections. So when I say I want to find the third quartile is the 75th percentile. So I'm looking for how far I need to go over until I collect 75% of my data. So 75% is equal to how many points do I have to count out of the total number of data that I have? And that should be 22. Solving this, we get y is equal to 0.75 times 22, or 16.5. So that's how many data I have to count. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6. 16.5 is right there in the middle, and I grab that 14th value. Or rather, I grab the 17th value, which is 14. So the third quartile, or the 75th percentile, is 14. So what is this data? This is the ordered times in seconds that 22 cars wait in a drive-through. So we can say that 75% of cars wait less than 14 seconds. All right, let's find the first quartile. So the first quartile is what separates the bottom 25% of my data. So 25% is equal to how many values do we have to count out of the 22? Solving this for y, we get y is equal to 5.5. So going up to our data, and we count 5.5 values. 1, 2, 3, 4, 5. 0.5 is right there in the middle. We grab 7. So 25% of people waited less than 7 seconds. Thus, the interquartile ranges. So by definition, the interquartile range is Q3 minus Q1. Right, it's the distance between the 25th percentile and the 75th percentile. So it's pretty much how wide is the middle 50% of your data. This will be 14 minus 7, 7 seconds. So the middle 50% of people wait a wait time 7 seconds away from each other.